Alright, a school is trying to make some money, as they should do, because they have an excellent drama production going on, right? And they need to recoup some of the costs. So the revenue from selling tickets for a price P can be modeled by this function. So as you tweak the price P, the total revenue predicted changes. Now there'll be a sweet spot where if you have the price that's like high enough, so you make a good amount of profit, but low enough so enough people so you have a full house, right? You would make the most profit. So this model is trying to predict that. It is a very simplified model, so it won't be perfect. And we're asked to use this model and calculus to find the maximum possible revenue. Right, so what price should we make the tickets, and then how much revenue would we generate at that price? All right. So first of all, before we even attempt this problem, I'm going to graph it. And I'm doing that just so I can visualize the problem and just understand it a bit better. So I will graph this right hand side, so 40, instead of P I'll just use X, bracket 29 minus 2X, bracket, execute, draw. Now my window is very weird, so let me adjust that. So minimum 0, 20, 0, maximum draw. There we go. So I do actually know a bit about the problem, so I know what I could adjust my window to. However, you might not know, so that might actually take you a bit longer. But this is just to learn from. So looking at this, it is a negative parabola, and we can see that there's definitely a maximum, right? A maximum profit or revenue for a certain price. And if I do gsolve max, in fact, when the price is $7.25, we will have a maximum profit of $4,205. So, in fact, we already know the answer. However, the question is telling us to use calculus. So let's use some calculus. Before that, let's plan out how we'll approach this problem. So firstly, we will find the rate of change, right, the gradient function. And we want to do that so that we can set that to equal 0 to find the turning point. Is the gradient at a turning point, so a maximum or a minimum, is 0. So if we have the gradient function, we set it to equal 0, we can find out the price that corresponds to the maximum. So to find turning points, P value, right, or price. With that price, we can find revenue using our original equation and the P value, right, the price that we just worked out. Cool, so those are 3 steps. So step 1, finding the derivative. To do that, I will first expand the brackets. So what's that? 40 times 29, 1160p, and then minus 80p squared. And I did that so we can easily differentiate it. So r prime of p, so the derivative of 1160p with respect to p is 1160. The derivative of minus 80p squared, 2 times minus 80 minus 160, and then subtract 1 from the power. Alright, so we found the first derivative. Let's Step 2 is to equate that to 0. Equating it to 0, and a reminder, we're doing this because we know that the maximum or the minimum, so the turning points, have a gradient of 0. So we set our gradient function equal to 0. So let's solve for p. We'll add 160p on both sides. 160p. Then divide both sides by 160 to get p equals 7.25. Which is what we got by graphing it initially. So that's looking good. So that price, $7.25, will correspond to the maximum. So our last step is to find what that maximum is. So in our revenue equation, we will substitute $7.25. So in for P goes 7.25. And crunching the numbers, we get $4,205. And so just to write a short conclusion, if tickets were sold for $7.25, there would be a maximum revenue of $4,205. Alright, and if you got that far, finding the correct maximum, that is a merit. If you didn't quite get that far, you know, it happens, but if you found the derivative and you equated it to 0, that would be achieved, because you're showing you know how to differentiate, and you then know how to start using that gradient function to solve a problem in context. Alright, but moral of the story is make sure you go see your school's production and support them anyway.